So in section 3.3, we're going to be looking at graphing parabolas given to us in standard form and in vertex form. We're going to learn the formula for the vertex, and we're also going to learn how to take an equation from standard to vertex form by completing the square. So that's what we'll talk about in this section. And we'll end with a couple of applications problems so we can see, why might we be interested in the vertex. So here we go. So this is going to be an equation given to us in standard form. We've already learned that, okay? Now the A here, if it's positive, then we will have an upwards facing parabola. If the A is negative, then we will have a downwards facing parabola. Okay. If the parabola is written in this form, this is great. This makes graphing so easy because the vertex is very easy to find. You're just going to take the opposite of this. Instead of minus h, it's going to be a positive h. And you're going to keep this one exactly the same, positive k, positive k. The reason why we're changing the sign on this is because you're really setting this equal to 0. So if you took something like x minus h and you set it equal to 0, well, you'd have to add h to both sides. And that's why it ends up becoming the opposite sign of what you would think, okay? All right, so this is vertex form. This A will always tell us which way it's facing and how wide or how narrow our parabola is going to be. Okay, so the axis of symmetry is something we're also going to find in this section, which is just a line that slices the parabola perfectly in half so that it's symmetric on both sides. And so it turns out that that line will always pass through the vertex, and that's why it's going to share its x value with the vertex. You can see here that the h is going to be the axis of symmetry, and then up here the vertex is h. And that makes sense because let's say my vertex was 1, -3. Okay, so this is at 1, -3. Well, then the axis of symmetry here would have to pass through the x value of 1. Okay, so you don't even have to do much work. If you have the vertex and somebody says, what's the axis of symmetry? You're just going to say x equals h. You're going to give the x value out. All right, so here we go. So this one is already given to us in vertex form. We can quickly see what the a, the h, and the k are going to be, right? Okay. All right, so I'm just going to write down the vertex form right above it, just so we get kind of used to memorizing this. Okay, and so you can see that this is in vertex form. Okay, so the vertex would be the quickest thing to find. So the vertex is going to be at +3, -9, okay? So on this one right here, you always change the sign because you're setting it equal to 0. So instead of -3, it's +3. On the back end, you always keep the sign as is. So I always tell people, change it, don't change it. Change it, don't change it, okay? And the a would be 1 in this case. We'll talk more about that in a little bit. Okay, identify the vertex, done it. So now we got to get the x and the y-intercepts. So we could do the axis of symmetry. We might as well while we're here, right? We said that the axis of symmetry is just taking the x value of the vertex. So it's going to be x equals 3. And we'll also show that in the graph, okay? All right, so now we got to get the x and the y-intercepts. It's been a while, but we did do this earlier in the semester. If we want to find the x-intercepts, we have to let y be 0. If we want to find the y-intercepts, then we have to let x be 0. We're going to do opposites. All right, so if we let the y equal 0, which by the way, you might as well say let f of x be 0, right? Because y is f of x. So we're going to go ahead and substitute a 0 in right there. Okay, so I'm going to go ahead and add 9 to both sides to try to isolate whatever's being squared. So we get 9 equals x minus 3 squared. Then we're going to square root to get rid of the squared. Those are inverses. inverse operations. So we get, don't forget your plus or minus 3. Okay. All right. And then from there, let's move this over a bit. I'm getting squished, right? From there, it might be easier to look at it this way, you guys. X minus 3 equals plus or minus 3. We're going to move the 3 over. Sorry, I've already told you guys lefty issues. I rest my hand on the wrong spot on the screen all the time. Okay, so this is going to be x equals positive 3 plus or minus 3. So if we do our two cases, right? Oops. One case is going to be 3 plus 3. So that's going to be x equals 6. And then the other case is going to be 3 minus 3. So that's going to be 0. Now, they won't accept this if you're on an online platform for your homework. You have to write it as an ordered pair. Remember, we did let y be 0. So these are going to be our x-intercepts. We're going to have 2 of them, right? So I'm going to go ahead and graph those in the graph right now. So 0, 0, and 6, 0. Okay. Now we're going to let x be 0. So we're going to substitute a 0 in anywhere where we see an x. Okay, 0 minus 3 is negative 3. Negative 3 times negative 3 is 9. And 9 minus 9 is 0. So 0 for the x and 0 for the y. Now, by the way, if you ever see 0, 0 on one of them, it's got to show up on the other one. Because I don't, on a graph, let me graph 3, 9, 3, negative 9, 3, negative 1, 2, negative 9 right here. Okay. This graph is going to cross at 0, 0, right? Well, that crosses both the x and the y-axis there. So that's going to be both an x and a y-intercept. Unlike this other point right here, that's only an x-intercept. I'm not crossing the y-axis there. Okay. So I think we got everything it wanted us to get. Now I'm going to draw that axis of symmetry. We said it was x equals 3. So here's 1, 2, 3. This is where x equals 3 is. And yeah, of course, it's going to go through that if we want it to be symmetric on both sides. So I'm just going to go ahead and graph them and put them in the picture. Let's label them. Okay. So we have our vertex of 3, negative 9. We have our axis of symmetry of x equals 3. And then we have our x and y intercepts. Now, they want us to talk about the intervals on which it's increasing and the intervals on which it's decreasing. So I'm going to go ahead and put increasing in here. It wants us to use interval notation. So let's go ahead and do so. So it looks like we start off going downhill from left to right, right? So we're starting off decreasing. Now remember to give x values, not y values here. We're decreasing from negative infinity all the way up till x equals 3. 3, this line 3 right here where this axis of symmetry is, that's going to be where it changes, because now on the other side of that, now from left to right, we are going uphill, we are increasing. So that would be from 3 to infinity. Now remember, this negative infinity throws people off because they see that this is going up. But we're not looking at the y values. We're looking at the x values. As I go more out this way, these are negative, bigger and bigger negative numbers, right? So from negative infinity all the way until 3, we're decreasing. I put that backwards, you guys. And from 3 to infinity, I need to flip these because I did not read. Okay, so let's try that again. Take 2. All right, the decreasing, right, was the negative infinity to 3. And then the increasing is going to be from 3 to infinity. Read that incorrectly. Okay. All right. So hopefully that makes sense. I'll try not to butcher the next one there. All right, here we go. Oh, by the way, it's always a parentheses when you're talking about increasing or decreasing, because this point here, we can't include it. We can't definitively say, oh yeah, right here it's increasing, or oh yeah, right here it's decreasing, because it's kind of the point where we change from decreasing to increasing, right? So we don't include it, which is why we always put a parentheses on the 3. Okay, let's try another one. So again, this one's given to us in vertex form. We can see, because the A is negative, that this is going to face downward. Face down. Okay, now let's go ahead and go in there and get the vertex. So remember, change the sign on this one because of the setting it equal to 0, but don't change the sign on the -1. So our vertex is going to be over 2, down 1. Now that tells us that our axis of symmetry is going to be x equals 2 then. It's going to have to go through the same x value as the vertex, right? So let's go in here and get our x and y-intercepts now. So to find x-intercepts, we let y be 0. And to find y-intercepts, we let x be 0. So we're going to substitute a 0 in for the f of x. Now I might do something differently than I did last time because I want to get it done more quickly. I'm going to add x minus 2 squared to both sides. Or if you like, you could just say move it over, right? So 0 plus x minus 2 squared is x minus 2 squared. All right. Then we'll go in here and we'll, you know what, I should have done that in blue, guys. Let me redo that. We'll go in here and we'll square root. And hopefully what you're noticing is that this would end up being imaginary, right? Square rooting negatives, imaginary. So what that's going to imply is that there are no x-intercepts. It's possible, right? Actually, that makes complete sense. We just got done saying that the vertex was at 2, -1, and that we're facing downward. Well, if we're facing downward, there's no way we're going to be able to cross the x-axis. So that makes complete sense. All right, let's go in here and get the y-intercepts. So now we're going to let x be 0. All right, 0 minus 2 is -2. -2 times -2 is +4. So this negative sign is from me just carrying that one down, right? So -4 take away 1 is -5. So 0 is the x, and -5 is going to be the y for our y-intercept. There we are, there's -5, you guys. All right, so I'm going to go ahead and draw my axis of symmetry in there. So we know it goes through x equals 2. And at this point, this y-intercept is going to have a mirror image on the other side because of the symmetry, right? So we can get a third point if needed. Sometimes they want 3 points, right? Well, there's your third point. And then we'll just go ahead and withdraw the parabola through that. Okay, so we got the x-intercepts, we got the y-intercepts, and we got the axis of symmetry. Okay, let me try to do the increasing and decreasing, you guys, just to, because I messed up on the last one. So I want to make sure that I don't confuse anyone. So this one actually starts off increasing. Okay, from left to right, you can see that we're going uphill now. So we're going to be increasing from -infinity all the way up until that dividing line of x equals 2. After we pass 2, we start decreasing. So we're decreasing from 2 to infinity. Again, it's infinity because we're going to the right where all the positive numbers are. I'm not looking at the fact that this is going down because I'm not looking at the y-axis. These are intervals of x. So I have to make sure I'm thinking about the x-axis. All right. So now, this arguably is the toughest part of the section today, and that is using the technique of completing the square to write this in vertex form. This can be challenging. We have two of them, so hopefully that's enough to help. All right. So it's not in vertex form. Remember that our goal is f of x equals a parentheses x minus h squared plus k. That's what we're working towards. So we're going to start off with the original equation. And you'll notice we aren't allowed to mess with the left-hand side, you guys. The left-hand side already matches the goal, right? This f of x has to stay at f of x. So all the math is going to be done to the right-hand side of the equation. All right, now I might do it differently than you've seen, which may be a good thing, right? So I always tell my students group together the first two terms only, and then you're going to factor out the leading coefficient. You're not going to factor out the GCF, just the leading coefficient. So right here, you can never complete the square when you have a leading coefficient ever. So we're going to factor out a 2. So if we divide by 2, we should get 10. And I'm going to leave a little space because I'm going to insert a number in here, right? I'm going to put some number here, okay? So that's when we use the formula for completing the square. The formula for completing the square is 1/2 b squared. In our case, b, the middle number, is 10. So half of 10 is 5, and 5 squared is 25. So we're going to be inserting a 25, but that's not really a 25. Because this 2 is distributing to it, it's really a 50. So what that means is over here, we have to do, I probably should have chosen a different color, a minus 50 to counterbalance it. It's okay to add 50 to a problem as long as you also subtract 50 from the problem, because that's really 0. So you've done nothing, okay? Now this is new. In the past, we would have added it to both sides, right? We would have said, okay, whatever you do to one side, you got to do to the other. If we put a plus 50 on the right, then we got to put a plus 50 on the left. But we just got done saying we're not allowed to touch the left-hand side. And so if you did add the 50 over there, you'd have to subtract them over to the other side anyways, right? And so that's why he ends up, being a minus 50 also, if you'd like to think about it that way. It's another way to think about it, okay? Now, a lot of students will do plus 25 minus 25. They'll forget to distribute this 2 in. Now remember, you want to figure out how did you change the problem. If we were to distribute this 2, right, into the parentheses right now, and I haven't written this yet. Let's pretend I haven't written it yet. If we look at the original 2x squared, 20x, 20x, 42, 42, there's this plus 50 in the problem. That's why we're putting a minus 50 in the problem, because those two are going to cancel each other out and you'll have the original problem right there. Okay. So you need to make a 0. You need to counterbalance whatever you added with the opposite sign. It might not always be like plus minus, it might be minus plus, but you've got to make sure that you counterbalance it. So hopefully that was a good enough explanation for you to understand. Now we just got to get it in our memory by doing it, a few times. Okay, so then we have this 2 that's hanging out, and we want to factor this polynomial, right? What we said in the last section, I think it was the last section, 3.2, that for completing the square, it always factors using this number over here, this plus 5, right? Positive 5 in this case, okay? Now you can always check and make sure that that's right. 5 times 5 would get you 25, and 5 plus 5 would get you 10. So this is the factorization of that problem. Okay, so now 42 minus 50 gets you -8. This should be kind of rough because it's your first go around of this, and that's okay, guys. So if you're feeling like, oh my gosh, it's perfectly fine. So now we got to get the vertex. Well, the vertex, remember, change the sign on that guy. So it'll be a -5, and don't change the sign on that one. So -8. All right, so that's our vertex. Now, to determine if it's a maximum or a minimum, use the A value to see if it's facing up or down. So let's just get a picture going and kind of talk this out, okay? If a parabola is facing upwards, facing up, then its vertex will actually be a minimum. But if a parabola is facing downwards, then its vertex will be a max. A lot of people will see a negative out front and say, oh, it's a min. But actually a negative will make it face downward, which will actually make the vertex a max, okay? So since our A is 2, right? A equals 2. That's going to imply that it faces up. So we have this particular case right here, right? So that means that the vertex would be a min, okay? Now the minimum value isn't the vertex itself. The minimum value is going to be the y value of the vertex, okay? And we'll do a graph, a sketch of the graph at least so you guys can see, okay? Here's my sketch over here. We have our vertex, oops, that's not really my sketch. -5, -8, right? So let's say this is -5, and let's say this is -8. And we have a parabola that faces upwards, right? Okay, something like that, just a sketch. So if somebody said, what's the minimum? They're saying, what's the lowest? Well, the 5 has nothing to do with it, the -5. The lowest value, if you trace it over here, is going to be the y value. So only report out the y value for the minimum, and the maximums too, same thing. Only report out the y value. All right, let's do another one like that. Write f of x in vertex form and graph the function. Identify the x and y-intercepts and the axis of symmetry. Write the domain and range in normal notation. And identify the maximum or minimum value. Boy, this is everything you could do to a parabola. This is great practice right here, okay? All right, so we're going to do the same process that we just did. We're going to do it by completing the square. This isn't the only way. We'll show you another way, but this is an important thing to know if you're moving on, okay? All right, so group together the first two and factor out the greatest common factor. I'm just kidding. Rewind. Factor out the leading coefficient. So we're going to factor out the negative, okay? Ooh, do not factor out the GCF, you guys. All right, so that's just going to change the signs. And then don't forget to leave a little space because you are going to be inserting a number here, right? You are going to be inserting something. So let's go ahead and do half of the squared would be half of 2. Half of 2 is 1, and 1 squared is 1. So we're going to put a +1 in there. Now it's not really a +1, right? When we distribute this negative to that, it's really a -1. So that means that right here, we're going to have to do the opposite and do a +1. So you're always, after you distribute, you figure out what that is. So a negative times a positive is a negative. You're going to do the opposite here. You can see that we have a -1 and a +1. On the last one, we had a +50 and a -50. So just make sure that those are always opposites of each other, and you'll be good to go. Okay, so we got A is negative, and then the factors of 1 that add up to 2, well, you can get that right over here in orange, the 1, right? Right before you square. So we know that this is going to be x plus 1. Let's check it really fast. 1 times 1 is 1, so it matches that. And 1 plus 1 is 2, so it matches that. Meanwhile, 3 plus 1 on the back end gets us 4. All right, so it's in vertex form. So now we can quickly answer what the vertex is. So remember to change the sign on the thing in parentheses because you do set it equal to 0, and don't change the sign on the last number. So -1, +4 is going to be where our vertex is, right? Okay, and then we could do the axis of symmetry. I'm just going to put AOS, you guys, axis of symmetry. And that's going to be, use the x value, right? So, oh, so I write the y value down. So that's going to use the x value. Good thing I was about to graph it and I checked myself. All right. So since, let's see here. I'm trying to read the directions. I'll talk about maxes and mins in a second. So remember to find the x-intercepts, you let y be 0. And to find the y-intercepts, you let x be 0. All right. So if we're going to let y be 0, you can use either one of these forms. I prefer the vertex form, this one down here, for when I let the y be 0. Just seems easier to solve to me when it's written like this. It's a couple steps, right? Shoot this guy, add this over to the other side so he's positive. Square root to get rid of the squared. Don't forget your plus or minus on the 2. Move the 1 over so that it's a -1. And then do your 2 cases. -1 plus 2 and -1 minus 2. So it looks like we're going to get 1, 0 and -3, 0. And you'll know when you go to graph it, you'll be like, that doesn't make sense. So 1, 0 and -3, 0 makes complete sense. That's going to make us symmetric about our axis of symmetry, which is x equals -1, right? I mean, my drawings are never perfect, you guys, but hopefully that you can imagine that that would be symmetric, okay? We've got 2 spaces away this way, right? 1, 2. And we got 2 spaces away that way, 1, 2. So that looks good. All right. Now for the y-intercepts, I actually prefer to use the standard form. Plugging a 0 into that is so easy. Anything with a 0 in it is going to get annihilated, right? So it just leaves me with this 3. How quick was that, right? So it looks like when x is 0, y is 3. So 0, 3 is our y-intercept. And I didn't really draw this right-hand side very well. Let me kind of go in here and redraw them, you guys, now that I know that. Plus it was kind of, oops, it's kind of ugly to begin with anyways. I don't think I put this point at the right spot. It was 1, 0, right? There we go. Okay. All right. Let's see here. What do we got? We got the vertex form. We graphed it. We got the vertex, the x and y intercepts, the axis of symmetry. Okay, we got to do the domain and range. That's new. And identify the max or the min. All right, so let's talk about the max and the min. So since A is negative, right? A is -1. A is the number in front, right, you guys? Since A is -1, it faces downward. Well, we already, you know what? I don't need to do this. We have a picture already. That's if you don't have a picture, right? You guys can see it faces downward. So let's just look at the graph to get the max. Okay, so the highest this graph ever goes is 4, right? And we said you don't even need the graph. It's just the y value of the vertex, okay? So the maximum value is 4. So if it faces downward, it has a max. That's really hard for some students. They want to say if it faces downward, it has a min. Okay, so now let's go ahead and get the domain, right, and range. Oops, domain, range. Okay, so the domain for anything that widens like this is going to be -infinity to infinity. It just keeps getting wider and wider. It goes to the left forever, it goes to the right forever. So since it widens, -infinity to infinity. The range, however, that's not the case, right? We said the absolute highest this ever goes is 4. Okay, so the lowest is -infinity. The highest is 4. Now, unlike the increasing and decreasing, I am going to include the 4 because the 4 is on the graph. So we're saying what y values are on the graph? Well, the lowest y value, there isn't one. It just keeps going down forever, so -infinity. The highest y value is 4, and it is on the graph, so we're going to include it. Okay, so we got all of the things they asked of us. Now, there is a formula to help find the vertex. That's a lot of students prefer this because the completing the square can be kind of tough for them. So x equals negative b over 2a is going to be the formula for the vertex, okay? So I'm going to kind of talk about that you don't have to memorize something new here. On your quadratic formula, which you do have memorized, hopefully, because that's an important formula. It's already there. And if I split this guy up and write him as two separate fractions instead of one combined fraction, we're going to talk about this isn't a coincidence that this is your vertex formula right here. Okay. What you're saying here is this is the middle of your parabola, right? It's the middle. So this would be negative b over 2a, right? And then you're going to add some to get to one x-intercept, and you're going to subtract some to get to the other, hence the plus or minus. And that distance has to be the same. However far I go this way, I have to go the same amount that way. And so this dot here on the right is going to be the negative b over 2a plus the square root of b squared minus 4ac over 2a. And this dot over here on the left is going to be negative b over 2a minus. Okay, and that's what's going to get you your parabola, right? Pretend I went through that dot, just make that bigger, problem solved. Okay. All right, so I'm not adding anything new into your mind. The big takeaway is, oh my gosh, I already have this. I know it's this part of the quadratic formula, and there's a better picture than my junky picture describing what we just talked about. Okay, so it says, determine the vertex by using the vertex formula and then writing in vertex form. So we're not required to complete the square on this one. We're just going to use the formula x equals negative b over 2a, and let's substitute in. We can see that the b is 48 in the problem, and we can see that the a is negative 3. So this is going to get us negative 48 divided by negative 6. So we now know that for the vertex, the x value is 8. In order to get the y value, substitute that back in to the original problem. So we're going to substitute an 8 in for all of the x's to help us figure out what the y value is. So let's just make a note here. Plug in to find y. Okay. I'm just going to pull out my calculator. This seems like some heavy number crunching. So let's see here, negative 3 times 8 squared plus 48 times 8 minus 165. So 27. Okay, so then 27 would be the vertex. Okay, so now they want us to write it into vertex form, right? They want us to put it in this form right here, right? Well, the a, we already know. We said that the a was negative 3, right? Now remember, to change the sign on the 8, it's going to be a minus 8 here. But to keep the sign on the 27. Okay. All right. 27 seems like a big number. Let me just do some checking really quickly. 64 times 3, 12, 192. And then, you know what? Let me just make sure that I type this all in right. Yeah, that looks good. Okay, it is 27. Okay. Make sure we did everything. Find the vertex by using the formula and then write it in vertex form. We indeed did do that. Okay. Example 6. Now we have 2 application problems and we're done. At the beginning of his career, at the end of his career, At the end of his career, Sherlock Holmes retired to a small farm in the country and took up a hobby of beekeeping. Being of an analytical mind, he could not just watch a bee fly from flower to flower. He formulated a mathematical model for the parabolic path the bee follows from flower A to flower B. The path is given by that formula, where x is the distance in inches along the ground from Sherlock. What is the maximum height the bee reaches as it flies from A to B? So they want us to find this, right? Okay, so that's going to be the vertex. Now we have to ask ourselves, does it want the x value of the vertex? Does it want that? Or does it want the y value of the vertex? And I'm going to claim that it wants the y value because it wants the highest it goes, and that could be found over here. So we're going to go ahead and say that we need to find the y value of the vertex. All right, so we have a formula. I'm looking at this equation and going, oh, I don't want to complete the square root of that. I'm definitely going to use the formula because of the decimals. So we're going to use the x equals negative b over 2a. All right, so if we substitute in b, which is 1.8, and a, which is negative 0.03, we get negative 1.8 over negative 0.06. Okay, so 6 goes into that 3 times. I'm thinking that the answer is going to be 30. Okay, well, let's just double check. 1.8 divided by 0.06. 1.8 divided by 0.06. There it is. There it is, 30. Okay, let's kind of talk about how I think of that in my head really quickly. How I think about that is I move the decimal 2 times to get rid of it here, which means I move it 2 times. I'm sorry, 2 times to get rid of it for both of them, right? If I only moved it once and made it 18, then I move it once here and give me 0.6, I'd still have a decimal. So I do have to move it twice to make it go away, and twice here would make 180. And that's how I was thinking about getting 30 in my mind, is just by moving it twice to get 6 and twice to get 180. Okay. All right. So we have the x value of the vertex, right? So we now know that this question mark right here is 30. But now we said we need to get the y value, right? So we're going to take that and we're going to substitute it back in to the original equation. Oops. Okay. So let's go ahead and get that calculator out again. Okay, here we go. Negative 0.03 times 30 squared plus 1.8 times 30, and then minus 3. Now we're dealing with inches, I believe. Yeah, inches, you guys. So the answer is going to be that the highest the bee flew was 3 inches. That's pretty low, huh? All right. Same model, different question. How far away from Sherlock are flowers A and B? So what we want to know is basically, if we're using mathematical language, I'm going to ask you to think for a second if you know the terms for what these are called. Hopefully you said x-intercepts, because this is where we cross the x-axis, right? Okay. So what we need is we want the x-intercepts. So let's set y equal to 0. Okay, to find x-intercepts, we let y equal to 0. All right, in this case, the f of x, that's y, right? Now, this is pretty gnarly. I would probably say let's use the quadratic formula for it because of all the decimals. We could move the decimals and divide by 3. Actually, it might not be that bad if we did that. Let me show you that just because the quadratic formula could be kind of boring. Let's see if this does make it any easier. So if we were to move the decimal 2 times, 2 times, 2 times, then we could turn this into 3x, negative 3x squared plus 180x minus 2400. The next thing I would do is I would go in and change all the signs because we don't, well, let me just do this. I would divide by a negative 3 because everything 3 goes into, and it's going to shrink it down and it's going to change the sign. We don't want that leading term to be negative. And now with the negative divided by a negative, it's not. Positive divided by a negative is negative. Negative divided by a negative is positive. So this is a lot simpler to deal with, just with a couple few quick changes, right? And so we're looking for factors. We could use the quadratic formula, but let's see if we can factor it first. So we're looking for factors of 800 that add up to negative 60. No, it can't be 80 and 10. How many times does 20 go into that? 40, right? Yeah, that'll do it. They would both need to be negative. Let's check. Negative 20 times negative 40 is 800. Negative 20 plus negative 40 is negative 60. Cool. So this will factor as x minus 20 and x minus 40. I'm just going to pick up over here. We're going to set each piece equal to 0. Move the 20 over. Move the 40 over. And we have that this one must be at 20 and this one must be at 40, which makes complete sense if the center's 30, huh? Okay, so how far away from Sherlock are flowers A and B? Let's go ahead and write a sentence here. Flower A is 20. Remember, we're measuring with inches. And flower B is 40 inches from Sherlock. Right. Okay, so a few examples to just kind of show you why we're interested in things like the vertex, right? And why we're interested in like the x-intercepts. We're gonna have one more example that's going to show us why we're interested in the maximums, okay? You know me, I love word problems. It makes it, the math makes sense, like, and it makes us see why we care. And it also makes it to where we can use it in our lives. We're not just able to answer these equations that are written on a paper, but we could set it up if somebody challenged us to. All right, a landscaper has enough stone to enclose a rectangular koi pond next to an existing garden wall of the Engelmann's house with 24 feet of stone wall. If the garden wall forms one side of the rectangle, what is the maximum area that the landscaper can enclose? What dimensions of the koi pond will yield this area? So I'm going to draw a picture. Sometimes my interpretation is not correct at first, but this is what I'm interpreting right now. I am seeing that we want a rectangular koi pond that's attached to a garden wall, right? So something like this is what, oh, that's not what I meant to do. Let's try that again. Okay. I'm going to take this because this seems like this is crooked. Select it. Show picture looks like that. Okay. I'm going to call that good enough. Okay. All right. So We've got our garden wall up here. And this is our koi pond, right? Okay. So we don't need stone wall for all four sides. What it's trying to say here in the directions is that we can use this garden wall as one of the sides of the koi pond. Okay. All right, and we're just going to go ahead and have three sides that we're going to use this stone for. We're going to have to divvy it up amongst those three sides. So if I'm kind of thinking about it, like maybe, let's say we use like 5 feet here and 5 feet here, right? Because those are the same size. That'd be 5 plus 5 would be 10, right? So then 24 minus 10 would leave us like 14 for this one. That's us using concrete numbers. Like what I want to do is go abstract with it because we don't know that it was 5 and 5, you know? So let's say that it was x. Well, if we use x here, then we have to use x here. X plus x is 2x. So we've already used 2x. So 24 take away 2x would tell us how much we have left for the other side. Okay. So it says that we need to find the maximum area. Okay, so the area of a rectangle formula seems like what we're going to need here. All right, and that's just going to be base times height, length times width, whatever. We'll use length times width. So I think we used that in the video for the last, or 3.2 part 2. All right, so the area, we don't know, but the length and the width, we do know. Looks like the length and the width are going to be x and 24 minus 2x, right? And the order doesn't matter. I'm just going to put the x first because I think that that's what visually most of us are used to. Okay, so length and width can be interchanged, right? Okay, so we'll go ahead and distribute. So this is a formula for the area. Now, we want to know what the maximum area is. And let's think about that. Since we want the maximum area, we're really finding the vertex. You know what, let's think before I go to typing, okay? What we have right now is an equation. And in that equation, the x-axis and the a-axis, that's our x and our y. And this is a downward facing parabola. If I were to write this in standard form with the x squared first, you can see that this parabola will face downward. It's actually going to look something like this. Okay, this part us not really caring about. All right, so if they want to find the maximum area, the vertex is what we're going to need. And particularly, we're going to need the y value of the vertex. That's going to give us the maximum area. This value down here, it's going to give us the x, which means it's going to help us find the dimensions that would yield the maximum area. So I'm just going to put right here, I'll write it out. This will be the max area. This will be the dimension that yield the max area. Okay. So if we can find the x value of the vertex, we'll know how long our length and our width will need to be. If we can find the y value of the vertex, we will know our maximum area. And it actually wants both. It says, what is the maximum area? But it also says what dimensions of the koi pond will yield this area. All right, so we're going to need the x and the y value of the vertex. All right, so let's go ahead and use the vertex formula. X equals negative b over 2a, right? B in our case is going to be 24. It's a good thing we rewrote it so we don't use the wrong a and b. And a would be negative 2, right? Oops. So 2 times negative 2. So that's going to get us negative 24 over negative 4. 6. So it's a good thing we're getting a positive number. If you get a negative number, at least you'll know. That's the good thing about a word problem. In an abstract problem, if you got a negative number, you just box it. But you're like, hey, I can't have negative 6 feet long for my koi pond, right? Okay, so we're going to put the 6 in here, but we're also going to drop the 6 in here too, right? So 24 take away 2 times 6 is 24 take away 12. So it looks like 6 and 12 are going to be our dimensions. So we already have that answer. But don't forget, we have to substitute the 6 back into the original problem, whichever one, right, you guys? So let's say we substitute it into the one that I've circled right here. Let's see, 4 carry the 2, 144. 6 squared is 36 times 2 is 72. I think that's just 72, you guys. So A equals 72. So this would be measured in feet. This would be measured in square feet, right? All right, so the length, the width, and the maximum area are the things that we need or that we found. So let's go ahead and substitute them in. We know that the length or width, whatever, it's arbitrary here, is 12 feet. The width is going to be 6 feet, and the maximum area would be 72 square feet. Cool. Another problem showing us, why we would care about these finding things like the vertex. All right, you guys, hopefully that made sense. It's a really important section, and it's giving us vertex form, completing the square to get vertex form, the vertex formula. And I know for our final that there are questions on the final about word problems too, like this. And you have to figure out if you want the X or the Y value of the vertex. So just an important section all around. All right, thanks for joining me, you guys. Hopefully you found this helpful. Take care.